All right, I'm going to talk about how do you find the oblique asymptote. Notice the degree of the numerator is 1 more than the denominator. This is degree 2, this is degree 1, and so we divide this. You do division of the denominator into the numerator. And since this is a single factor, we can do synthetic division. And so we'd have 3x squared plus 4x divided by x plus 2. Synthetic division, we have 3x squareds plus 4x's, and 0 is the constant. And we're going to divide it by what makes this be 0, minus 2. 3 plus nothing is 3, times negative 2 is negative 6. Add, we get negative 2. That's positive 4, and we get a remainder of 4. So we get 3x minus 2 plus 4 divided by x plus 2. Well, as x gets really large, when we're looking for in behavior and we're going way to the left or the right, this fraction goes to 0. The denominator gets very big, the numerator stays 4, and it goes to 0. And there's what the line is that you have. That's the oblique asymptote. You don't even have to know the remainder, just up to where the constant is. So if I were doing 40, I would do 2, 3, negative 8, and put a 1 on the outside, and 2 plus nothing is 2x. That's times 2. It's 5. 2x plus 5 is the oblique asymptote. The remainder I don't care about. There's the oblique asymptote. Now, in this one gets a little tricky. We've got a 2 there instead of a 1. So we can think of this as x minus 3 and a 2. So we got to divide by the x minus by a 3 and by the number 2. So I have x 1x squared minus 1x minus 3, and I want to divide by 3. 1 plus nothing is 1 times 3 is 3. Minus 1 plus 3 is 2. That's 6, and that comes out 3, but I don't care. I get 1x plus 2, but then I have to divide by the 2. So this divided by 2 and this divided by 2, and then I get 1/2 x plus 1. Now, if you don't like that, there's another way to do it. You could have done these all with long division. So I'm going to do this one again with long division. X squared minus x minus 3 divided by 2x minus 6. 2x times what makes x squared? It looks like it's got to be 1/2 to make the 2 times a half is 1. And by an x, 1/2 times this is x squared. 1/2 times negative 6. 1/2 x times negative 6 is negative 3x. Draw the line, change the signs. These cancel. I get 2x minus 3. 2x times what makes 2x? There is the oblique asymptote. There'll be a remainder, but I don't care about it in this circumstance because it'll be the remainder, whatever it is, divided by 2x minus 3, 6. And this is going to go to 0 when x gets very large or very small because the denominator will explode in size and cancel this whole thing out, make it go towards 0. So, long division. I'm going to do one more, 43, which is similar to some of the things you have to do over here. So 43 minus, since this is squared, I'm just going to go straight to long division. Minus 2 x to the third. Notice it's degree 3, degree 2, so it's going to be a linear, plus x squared minus 6x plus 7. And I'm dividing by x squared plus 3. I need to multiply by a -2 and an x times this will make this. So -2x times x squared is -2x squared. -2x times 3 is -6x. Draw the line, change the signs, and now I'm going to add like terms. Oh, x times x squared is x to the third. Yep, those are like. I multiplied wrong. Those cancel. That's what was supposed to happen. I'm going to have an x squared, and plus 6x and minus 6x are going to cancel, and I have a plus 7. And I don't really care much about this because all I need to know is what do I take x squared by times to get x squared? And I think that's 1. And it will be x squared plus 3. If I drew the line to change the signs, I get 4. And this would be 4 over x squared plus 3. But this is going to go to 0 in behavior. And there's the equation of the oblique asymptote, what they asked us to look for. Okay, that's how you find oblique asymptotes.